Thank you so much. So, good morning, everyone. So happy to join you here. So happy to see you. So happy to be in Greece. And actually, that's the first time I'm in Greece and in Athens. And that's basically a shame from my side. Since we're basically neighbors, I'm from Israel. But it's still my first visit here to Greece and to Athens. It's an amazing place, beautiful city. And actually, that is a photo that I took just last night. And I sent it to my family with a wow right underneath it. I took it from the window of my bedroom in the apartment that I'm staying in. Beautiful place, really, I'm having so much fun. And we are going to visit the Acropolis today evening. I'm sure it will be so good. But you are not here to listen to me rambling about Athens and Greece and the Acropolis, but you are here to listen to me talking about the API wars. Now, yesterday, as you probably know, was May the 4th. And that means that Star Wars reference is definitely in order. And therefore, a long time ago, in a city far, far away, I had a meeting with a client. And that was a client that I was working with him for quite a long time regarding the architecture of his systems. And he picked up the phone and he called me and he told me, listen, Memi, I need your help here. We are working on a new system, and we decided to implement its API using GraphQL. And everything works just as expected. The data is coming in. Everything is perfect, except one thing. The performance is abysmal. It's so slow. So please, come on, take a look at the code. Let's see if you can figure out what exactly is going on here. So this is exactly what we did. I visited him. We fired up VS Code. We looked at the code, and this is what I saw. The endpoint of the GraphQL was perfect. It was well designed, the schema was fine, everything did exactly what was expected of it. However, when diving deep into the code, to the part where the code should actually go to the database and retrieve the data, because after all, this is what most APIs in the world are doing, then what I saw instead of a code calling to the database, I saw a call to a REST API on a remote service. So that means that this code called another API, which called a database, and then returned all the data. Now, think how many network hops we had with this call. So the client called the GraphQL called the REST API, the REST API called the database, and then all the way back. So quite a few network hops, and that definitely explained why the API, why the GraphQL was so slow. And this is just a symptom. I can see with a lot of clients, a lot of organizations that I'm working with, that they simply don't know which API to select and how to implement it. And this is exactly what we are going to talk about today. So, we are going to discuss the most popular web APIs in the industry right now, which are, as you probably can guess from the title of this session, REST API, GraphQL, and gRPC. So, before diving in, a little bit about myself. So my name is Memi Lavi. I'm a senior software architect and cloud, and I've been doing that for a little more than 20 years. About 5 years ago, I founded a company, a boutique company for cloud and software architecture in Israel, and 3 years later, I sold it to one of the largest IT companies, again, in Israel. I'm a certified Azure architect working with security, IoT development, and of course, cloud architecture. In addition to that, I'm also a partner instructor in Udemy. You can see the numbers of my students and the numbers of my courses. Currently, I have 16. In about a month, that would be 17. The courses are sold all over the world. The number here is 185 countries, translated to 54 languages. And in addition to that, I also created, founded, and still managing this Facebook group. I believe this is the largest Facebook group for software architects, with a little bit more. This number is out of date. It's a little bit more than 22,000, so you are very welcome to join it. Very interesting discussions over there. Again, highly recommended. So what are we going to talk about in this session? First, we are going to have a quick introduction to the 3 APIs that we mentioned before. Again, REST, GraphQL, and gRPC. After that, we are going to talk about the pros and cons of each one of them. And as you can see, they are quite different from each other. And lastly, we are going to take a look at the API Flowchart, which is the flowchart that I use when I need to select an API for a specific project that I'm working on. Great, so let's begin, and let's begin with a quick show of hands, but I want to do that in a little different way. And what I want you to do, please, is take out your phones and point it to the screen and scan this QR code, and if for some reason the scan doesn't work, then simply navigate to slido.com and enter these numbers that you see there, and you will be presented with a short survey asking you what are the web APIs you are using today. And note that you can select more than one. So go there and answer your questions. What, sorry? There should be a survey over there. In fact, I checked it about an hour ago. If this doesn't work, then try and scan, if you can, this one. It's a little bit smaller. Good? Okay, great. So let's wait for the number. Okay, nice, nice. So, not surprisingly, absolutely not surprisingly, REST is the most popular API you are using by a very large margin. And why it's not surprising? That's because, and we will see that later, REST is absolutely the simplest web API in existence today. There is nothing more simple than implement web API in REST. And in fact, that's the main reason why most organizations are going for REST. Is that the correct API to use? Well, as we will see, not necessarily. So anyway, that's the state. I can tell you from my experience that reflects quite good on what's going on in the industry. So now let's move on and begin with our overview of the various APIs, and let's begin with REST. Now, before moving on, I want you to take a close look at my shirt over here. I hope you can see it. I'm a software architect. What's your superpower? And now it's your chance to get one of these. And in order to do that, this is what you need to do. Take a look at how REST is written. And as you can see, it's all capital, which means it's an acronym. So my question for you is, who can tell me what REST stands for? Yep, you there. Exactly, great. Come to me later, get your shirt, okay? Great. Amazing. So the answer is representational state transfer. And I want you to note that I'm not sure how many you are, I guess about 300, 400, something like that. Only 2 raise their hands. And that shows something. So basically, that is what REST is all about. Representational state transfer. Now, most developers, when I tell them that, the first reaction is this. I mean, what the hell? REST is so simply, what is this representational state transfer? Well, let's dive in and explain that. So basically, when we say representational state transfer, what we mean is that REST API enables us to transfer the representation of a resource's state. I'm sure that's much clearer. In the rare case that is not, then let's take a look at an example which will clarify everything. So let's say we have a client and we have a server. And the client sends a request to the server for a resources state. Now you can safely replace the resource word with entities. And that's because with REST we work with entities, and we will talk about it quite a lot later. So basically the client goes to the server and asks for the entity's state. Now what is that word state? What does it mean? So basically when we talk about state, we mean one of 2 things. We either ask for the entity's properties value, and anyone here who learned object-oriented knows that an object is basically the definition of the sum of the value of its properties. So a car, for example, is defined by its color, by its engine, by its, I don't know, steering wheel, and so on. So that's one way to understand state. What's the second way? Well, if, for example, we want to delete an entity, then what we want to get back is not the entity itself, of course, but a confirmation that this action was, in fact, successful. So that's the state, either the entity or the result of an action we did on an entity. So anyways, that's what the client is asking for the server. For example, the client might be asking for order number 17. Now, the server gets a request, does whatever it needs to do, and returns, and note what it returns. It returns the resource's state representation. So it grabs the resource and its state and represents it in some way, and this is what it returns to the client. So, for example, in this example, the server will return the representation of order number 17. Now, that's fine, but this is a very, very high-level overview. Now, let's start talking business. Usually, or always, actually, when we talk about REST, we are going to implement it using the HTTP protocol, of course. How is it going to look like? Well, it will look like this. And note first the request over here. We have an HTTP verb of get, which indicates to the server that now we want to get something. And then we specify what is the entity that we want to get. In this case, we want to get order number 17. This is how we indicate that in a well-formed REST API. If the REST API is not well-formed, then we are going to see something entirely else. And what does the server returns to us? Again, a representation. How do we represent entities with most web apps? Of course, using JSON. So that's basically the philosophy behind REST, and this is what we want to see when we look at REST API. So again, a URL pointing to an entity and some representation of this entity. Great. So that's the philosophy. Let's take a quick look at REST. And is it on? Yes, it's on. Okay. And let's go to this API. And this API is one of the funniest that I know of. I have no idea who is behind this API. And what it does, it tries to guess your age based on your name. It's funny just like that. So let's try it. Let's put in my name, Memi, and let's hit enter, and it guesses that my age is 58. Now, I don't want to disclose my real age, but it's not 58. Let's give it another try. And let me tell you a secret. Memi is not my real name. That's my nickname. That's what anybody call me, including my family, my amazing wife that sits right over there, my colleagues, my friends, everyone call me Memi, but it's not my real name. My real name goes like this, and in order to read it, it should be better if you speak Hebrew. Any Hebrew speaker here in the audience? Beside my wife? No? Okay, so the way you read this name is Menachem. And if you go to anyone from Israel and ask him, what do you think about the name Menachem, he will tell you, that's an old name. So let's see. Let's hit enter on Menachem, and now I'm 71. So I'm not 71. Let me promise you that. But the real important thing here is that while it's on. Is it on? Yeah, okay. That while the guess was, of course, wrong, the API itself is just fine. This is how we want to look at an API, at a REST API. And you saw that the only thing that I needed in order for it to work is a browser. That's all, a browser and a URL. So, the most important thing when we are dealing with REST API is the URL. The URL is the thing that sets whether this API is pure gold or, and excuse me for the language, is garbage. We are just looking at the URL. And your URL should look something like that, and not the various parts of the URL. And let's go from the left to the right. First, we have the API word so that the developer will know that he's working against an API and not against an HTML page, for example. Then the version, which is something that is often overlooked by a lot of developers, but you always need to specify the version of the API. Later, we have the entities that we want to deal with. Its ID, that's an optional. Sub-entity, again, optional, of course. And then the parameters that we want to send to the server. So this is a well-formed URL, and if yours looks completely different from that, then we need to talk. But again, some components, of course, are optional, and you don't have to include all of them in all your API calls. So let's summarize REST API. First, it works with entities, and that's an extremely important part. It works with entities, not with actions. When I work with REST API, I go to an entity and do something with it. Next, it is based on the HTTP protocol. We talked about HTTP verb. We get back response code, HTTP response code. And of course, we work with URLs. In addition, it works with a request response paradigm. The client sends something and awaits a response. If you want to implement, for example, push notifications from the server to the client, well, with REST API, unfortunately, we are out of luck. And lastly, it is ridiculously easy to implement. Again, no matter what is the development platform that you are using, you will probably need no more than 2, perhaps 3 lines of code in order to implement REST. Now, that's nice. However, it comes with a warning. And the warning is that since it's so easy to implement, it is also so easy to implement wrong. And I really can't count the amount of times that I did a code review or an architecture review to a customer, and I looked at the API, at the REST API, and my mind was blown. I mean, this is not how REST API should look like. But again, it's so easy to do it wrong, so quite a few actually do that. So that was REST API. Now let's move on to our next candidate, which is, of course, GraphQL. And let's begin with a short history lesson. So GraphQL was developed by Facebook, correct? It developed by Facebook first for internal usage at 2012. And they developed it as a replacement for REST API because they wanted the flexibility. With REST API, when we ask for an entity, we are going to get an entity, no matter how this entity looks like. And if we want to retrieve only part of this entity, well, again, we are out of luck. We can't do that with REST API unless we are using something very special that we will discuss later. On 2015, Facebook released the second version of GraphQL and also released it to the public. Currently, GraphQL is managed by the GraphQL Foundation. Now, what are the basics of GraphQL? Well, first, and that's important to remember, it's a specification and not an implementation. There are quite a few implementations, and no matter what is your development platform, you have an implementation for GraphQL. Next, with GraphQL, we can define the structure of the data that we want to retrieve. And that actually is the major selling point of GraphQL. And that's why it was created in the first place. When we ask for an entity, we can define which fields from this entity we want to retrieve, and that's a very strong point of GraphQL. Next, it is JSON-based, as opposed to REST API, which can work with whatever we throw at it. GraphQL works only with JSON, and it has 3 types of operations, which we will cover in just a few seconds. In addition to that, it is schema-based, and the schema is perhaps the most important part of GraphQL. The schema basically defines for GraphQL how the data looks like. Think database. We have tables, we have columns, we have types. The same goes also with GraphQL. So before doing anything with GraphQL, we will first need to define the schema of the data, and GraphQL will work based on this schema. And of course, it is cross-platform. Now, we mentioned that there are 3 types of operations in GraphQL, which are, first, the query. You can guess from its name exactly what is query, and we run query in order to, well, query data. Next is mutation, which is basically just a fancy word for insert, update, and delete. This is how we change data with GraphQL. And lastly, we have subscription, which again, as the name suggests, we can use it in order to subscribe to events from the server. And note that we didn't have something like that with REST API, but with GraphQL, we do. Now, let's be honest here. 99% of the organizations that will go with GraphQL will not do that for the mutation or the subscription. They will do that for the query, because this is the strongest point of GraphQL. And this is usually the reason why organizations will go with GraphQL. Now, how do we work with GraphQL? Well, basically, there are 4 main steps of doing that. The first one and the most important one probably is defining the schema. Again, how the data looks like, the underlying data. Next, we are going to define the queries that we are going to run against this schema. Next, and that's an optional step, if we want, we can also define the mutation and subscription of the API, again, completely optional. And lastly, we need to implement the logic. And I must tell you that there are quite a few developers that are very surprised to see the last one, because they think that GraphQL is some kind of dark magic. I mean, take a database, slap GraphQL on it, and we can query it. Well, no, that's not the case. It's true, there are some libraries that will do just that, but again, that's dark magic. And you always need to know what exactly is going on behind the scenes when you're working with your database. And therefore, in most cases, you will need to implement the logic to actually go to your data source, whatever data source it is, and retrieve the data back to the GraphQL and from there to the client. So let's take a quick look at GraphQL. And let's go back to our loyal browser. Now, when working with GraphQL, we said that there are quite a few implementations. The one thing that is common to all these implementations are they are all coming with a GraphQL Playground. And with the Playground, we can view the schema, we can run queries, we can basically test the API without actually developing a client. And this is what you see here. So this is a Playground for the implementation that I use. And what we expect to see here is entities and queries. And here is an example for an entity. This entity is called book, and of course it has all the fields that we expect from a book. We have book ID, it has a name, pages, price, publish date, and so on. And also, of course, as in a real database, a type. It can be int, string, another int, and float, and the exclamation mark right here indicates that this field is not nullable. Now, in addition to primitive types that you can see here, we can also use complex types. For example, take a look at this field, the author of this book. And the type of this author field is also author. And if we will scroll down, we can see the author type, which in this case has two fields, author ID and name. So that's basically a schema. This is how we define entities. Now, if we will scroll up a little bit, we can see also the queries that we can run against our schema. And let's take a look at the first one. It is named books, and know that I can name it whatever I want. I can call it, I don't know, David. Books is just a name. It's not an indicator of what exactly is going to be returned. This query receives one parameter named name contains, which is of type string, and it returns a list of books. So that's how query looks like in the schema. And now let's see it in action. So let's go back to the operations tab right here. And here is a typical query. So here is the name of the query. Here is the list of fields that I want to retrieve from the book, and from the, for the author entity, I want to retrieve only the name. So this is how I specify the fields that I want to retrieve. And if I hit run, well, you already had it here. Let's put it right there. So you can see that this is exactly what we got. We got a list of books with the name, pages, and the name of the author. Now, we said before that the major selling point of GraphQL is that we can specify which fields we want to get back, and we should do that easily. So let's do just that. For example, let's add below pages, let's add the price field. That's all we need to do. Let's run this query again. And we have here the price field added to our result. Now, again, theoretically, the book entity can have, I don't know, 100 fields, but we will retrieve only the fields that we actually need. And that's the beauty of GraphQL. So let's go back here. Great. So that was GraphQL. Now, what are the most important parts when working with GraphQL? Well, the first one is the schema. We can't do anything with GraphQL without schema. We can't write a single line of code if we don't have a schema in place. So therefore, that's the most important part. Next is the query or queries, where we define how exactly we can query the data that is defined in the schema. So these are the most important parts of GraphQL. So let's summarize. GraphQL works with entities. It uses proprietary language. If you saw when we looked at the schema, it is based on some language that was developed by Facebook. Agreed, quite easy to learn, but still a new language. It supports the request-response paradigm and also a subscription implemented behind the scenes using WebSocket. And also not so easy to implement. We need to define the schema. We need to use a third-party library and never, ever even think about develop your own GraphQL implementation. This is just a waste of time. Focus on what's really important, which is your business. So that's GraphQL. And now let's move on to the last contender, which is gRPC. And gRPC was developed by Google, hence the G. So gRPC was developed by Google, again, first for internal usage on 2012. It was called Stubby. I have no idea why they chose this name. And on 2015, they made it public and released the next version, the second version of it, and then called it also gRPC. And why did they do that? Well, three main reasons. First, they wanted performance. REST API was simply not fast enough. Next, they wanted something that is beyond request response. They want more paradigms that will be supported. And lastly, they want flexible syntax. Because with REST, our syntax is basically decided upon using the entities that we are going to retrieve. But with gRPC, we can name the endpoints whatever we want. So let's see what are the basics of gRPC. First, it is based on the HTTP2 protocol and not on the classic HTTP, which most of us still use, which is the HTTP 1.1. Either anyone here knows when was the HTTP 1.1 standard released? Anyone? Well, the answer is, listen well, 1997, in the previous millennia. And we are still using it. And it is completely outdated for the modern web. And therefore, gRPC is based on HTTP2 protocols, allowing it to first use binary payload and not only text-based payload, and also to stream data. And gRPC definitely takes advantage of these capabilities. And next, it is an RPC-style API, and we will discuss RPC in just a second. Also, it has multiple communication styles, and we will discuss this also. And it uses protobuf as payload. Now, for those of you not familiar with protobuf, that's basically a way to serialize payload to binary format and to compile clients that can work with this binary payload. It can be used outside of gRPC. It's not tied to gRPC. It's quite popular. Now, we mentioned that gRPC works as, well, RPC. Who here knows what RPC stands for? Anyone? You? Yeah. Remote procedure call, exactly, very nice. What is remote procedure call? Well, here is how it goes. So it says something like that. You have your code, and you call a method. Now, from the point of view of your code, the method is right here. It's part of the code. It's local to the process. But behind the scenes, this method actually calls a remote procedure, a remote method, which is hosted on a remote service, probably on a remote server. Now, again, from the point of view of your code, you have no idea this is what's going on. But this is how remote procedure call actually works. Now, this is not a new idea. In fact, it's a very old idea. And all these mechanisms actually used a remote procedure call. Now, I really want to know, I'm really curious about that. Either anyone here in the audience who has the honor and opportunity to work with all four, Corba, EJB, DCOM, and SOAP. You, wow, amazing, a lot of respect and salute. I mean, which one was, and again, excuse me the language, which one was the most pain in the ass to work with? EJB, really? Wow. Wait, my clear winner here is DCOM. Sleepless nights going through registries in ancient Windows Server, really awful. So thank you, really, a lot of respect. So that's basically RPC. Now, we mentioned also that gRPC supports various communication styles. And in fact, it supports 4 of them, which are, first, unary, which is just a fancy word for request response. The second one is client streaming, which, as the name suggests, allows the client to continuously stream messages to the server. Think chat, for example. The third one is server streaming, which is the exact opposite, allowing the server to continuously stream messages to the client. Think stock quotes. And the last one is bidirectional, which does both. Think chat about stock quotes. Now, it's nice, however, there is a little nasty surprise hiding in there, and this is it. These 2 communication styles, the client streaming and the bidirectional, are not supported if you are working directly from the browser. And in fact, currently, as of today, there isn't any formal support for running gRPC directly from the browser using, let's say, JavaScript. And that's because all the payloads that we discussed earlier, which is simply is not supported by browser. So if you are thinking about gRPC, remember that and never ever try to use gRPC directly from the browser. Again, it's a doable thing. I did it myself, not supported. So that gRPC, let's take a quick look at it. And as opposed to what we saw earlier, I'm not going to show you gRPC that actually runs, because again, I can't do that from a browser. What I want to show you is the protobuf, or the proto file that defines how gRPC is going to look like. So we have a service named greeter. And this service exposes a single endpoint named say hello. And that means, if you remember our explanation about RPC, that means that in our local code, there will be a method named say hello that behind the scenes will go to our gRPC server. So say hello receives 1 parameter named hello request and returns hello reply. And we can see here the definition of these 2 messages. Here is the hello request containing 1 variable named name and hello reply with one field named message. Based on this file, we are going to compile a client and a payload of gRPC and use it in our local environment. So this is how you begin to use gRPC. Okay, great. That would be helpful. So what are we looking at when we talk about gRPC? What are the most important parts of gRPC? The first one is the protobuf. It is quite similar to the schema concept in GraphQL. But before we have protobuf, we can do nothing with gRPC. With protobuf, we define the service, the endpoints, and of course, the payloads. The second thing that we are looking at are actually the endpoints, because this is what we are going to actually call. This is the, let's call it URL, although it's not really URL, but this is the imaginary URL that we are going to work with. So let's summarize gRPC. First, as opposed to REST API and GraphQL, it works with actions. If you remember the name of the method that we just demonstrated, say hello, do something, write to log, turn on the air conditioning, whatever. But do something. It's not entities. Next, it does not work with browsers. And really, I hope I'm not disappointing anyone here, but it was really something that you should keep in mind. Next, it supports the request response paradigm plus streaming, and it does so extremely well. The streaming works really good. And it's not so easy to implement. Again, we need to have a protobuf in place, we need to compile it to client, and then with the client, we call gRPC. It's not as simple as REST API. So, that was a quickish overview of the APIs, and now let's start comparing them. And let's start with the simplicity of using them. And here we have a clear winner. REST is hands down the simplest to work with. Again, no matter what is the development platform you are working on, you probably won't need more than 2, perhaps 3 lines of code to have a full-blown, fully functional REST API. With the other, it's going to take much more work than that. Now, what about flexibility? Well, here we also have a clear winner. In this case, of course, GraphQL. That's the whole point. That's why it was created in the first place. Now, note something interesting. We can have flexibility with REST API if we are going to use something that is called OData. Anyone here works with OData? One? Unless I'm missing some, no, one, okay. So, yeah, that reflects quite well on the destiny of OData. So OData is a protocol created by Microsoft, I believe about 10 years ago, perhaps a little bit more, which basically did to REST what GraphQL did to REST. So it allowed us to retrieve and get entities using REST API and also specify what are the fields that we want to retrieve, including some more advanced features such as sorting, ordering, filtering, and so on. As you can see, it didn't gain a lot of traction, and not many are using it today. Now, what about performance? Well, again, remember, gRPC was created for performance, and therefore, not surprisingly, is the fastest protocol out there. However, note the VIX on the REST column. And the reason it's here is because REST, after all, is quite a basic layer in front of our code. It's not like gRPC or GraphQL, which involved quite a lot of libraries, development, and so on. REST is really, really thin. And that means that what really gonna dictate the performance of REST API is your code, not the rest. Not the fact that you are using REST. Now, of course, there are things that will going to happen when using REST, serialization, deserialization, security, SSL, TLS, all this stuff. That's right. But still, the effectiveness of your code is a major factor in the performance of REST. Next is push notification. Well, here the story is very simple. If you are using REST API, sorry, you are out of luck. You can't implement push notification using REST. With GraphQL and gRPC, as we saw, it is possible with GraphQL using subscriptions, with gRPC using server streaming. Next is whether we have native browser support. So again, quite simple here. From REST and GraphQL, absolutely yes. With gRPC, well, probably not. Again, technically it's possible. I wouldn't recommend it. And lastly, the semantics of this API. So REST and GraphQL are based on entities and built around entities, and gRPC is built around actions. Now, you don't need to memorize this table. You can simply go here. That's a special web page that I created on my website. You can see there the table and do with it whatever you want. Great. So that was a comparison of these APIs. And now I want to present you with the API Flowchart, which is a flowchart that I use when I need to decide which API I'm going to use on a specific project. And again, every project has its own requirements, and therefore every project might implement its own web API. So let's begin. The first question I'm going to ask is, are we going to call the API from a browser? Now, if the answer is yes, then the next question is, are we going to work only with predefined entities? Meaning, if, for example, we have an order entity, are we always going to retrieve the very same order structure? Or sometimes we want to retrieve only part of the entities. Or perhaps we want to retrieve the order and the related order items. So that's basically the question here. And if the answer is no, meaning we are not going to work only with predefined entities, then we will go with GraphQL. If the answer is yes, then the next question is, are we going to require push notifications in our system? And here, also, if the answer is yes, we are going to implement the API using REST and WebSockets. Again, REST doesn't have built-in support for push notifications. We will go with WebSockets for that. If the answer is no, then, well, only REST. So that was the left side of the equation. Let's now take a look at the right side. So what will happen if the answer for the first question is no? We are not going to call the API from a browser. Well, in this case, the next question is our system performance sensitive or requires streaming? So if performance are extremely important for us, then in this case, we will go with gRPC. The next question is our app actions-oriented or entities-oriented? Are we going to work mainly with entities, or are we going to tell the backend to do something? And if the answer is yes, it is actions-oriented, then we are going to go with gRPC. And if the answer is no, then we are going to be routed right here and continue from the very same point that we were before. Now, again, you don't need to memorize it. You can do it if you want, but you can also, again, go to this page and you will have there the flowchart that we just demonstrated. Okay, so I'm afraid we are out of time for questions, but I am going to stay here for a few minutes, so feel free to come, say hi, chat, ask whatever you want. And in the meantime, really, thank you so much. It's been a pleasure. Enjoy the rest of the conference, enjoy Greece, and enjoy Athens.